Welcome back. Let's do trigonometric functions, but we'll start by revising what you've done in the previous grades. Okay, so what is the domain? We're going to talk about the domain. Domain is a set of values used to draw the graph. We'll say these are the x values or the input values. The input values. The values that we put into the function, and then to get what? To get the output values, which is the range. So range, these are the output values. The range is a set of y values used to draw the graph, and then the amplitude. The amplitude is half the difference between the maximum and minimum y values. We use this formula. Please make sure that you use this formula every time. Don't just look at the graph and think that you can read the amplitude from the maximum value. No, we have to use the formula, this formula. We'll do this as we do examples, right? Then the period, right, is the number of degrees to complete a cycle. Let's discuss these concepts in detail. Let's start with the domain. Right, the domain for trigonometric functions is from negative infinity to infinity, but we cannot deal with functions that have a domain of negative infinity to infinity. So we have to restrict our domain. So it can be restricted. In this case, our domain is from negative 360 degrees to 360 degrees. But it can be restricted anyhow. It can be from 0 to 360. It can be from negative 90 to 270. It can be any restriction. So we're going to look at that as we do examples. We're going to be having different domains. But just know that the trigonometric functions, they start from negative infinity and end at positive infinity. But we restrict the domains for a particular case. Like in this case, our domain is from negative 360 to 360. That's the domain. Okay, for this case, right? And then this is the domain for all the graphs. And then the range. Let's discuss the range for y is equal to cos x and y is equal to sin x. All right. What are the y values? The y values are from negative 1 to 1. You can put your x values. You can put your x values from negative 360 to 360. But the y values you're going to get for these two graphs, y is equal to sin x and y is equal to cos x, will be from negative 1 to 1. The range for these two, y is from negative 1 to 1, negative 1 included, 1 included. What about the tangent graph? Y is equal to tan x. It does not have a minimum, it does not have a maximum. You see that? It goes on, goes on. So it means our y value will start from negative infinity to infinity. So you can say y is an element of real numbers, or you can say y is from negative infinity to infinity if we prefer to use the interval notation. And then the amplitude. Like I said, you have to use the formula. You have to use the formula. Like for y is equal to sin x, we look at the black graph. So it's from the maximum is 1, and then the minimum is negative 1. So you say amplitude is equal to 1 minus negative 1 divided by 2. And then you get what? You get 1, because 1 minus negative 1 is 2. 2 divided by 2 is 1. For y is equal to cos x, same thing, because the maximum is 1 and the minimum is negative 1. Okay, even negative 1 there, 1 there. So the maximum is 1, the minimum is negative 1. So you say 1 minus negative 1, which is 2, and then divided by 2, you get 1. For y is equal to tan x, like we said, we don't have the minimum, we don't have the maximum. It goes on to infinity, goes on to negative infinity. So we don't have maximum, we don't have minimum, so we don't have an amplitude when it comes to the graph of y is equal to tan x. Okay, so the amplitude there is 1, then the amplitude there is 1, and then no amplitude there. We'll see how this value a affects the critical points for the tan graph. But this one, we know that here there's a 1, that's why the amplitude is 1, and then here there's a 1, that's why the amplitude is 1. We'll discuss these as we discuss the parameters. Period. What is a period? We said a period is the number of degrees that are needed to complete a cycle. Right? Let's look at the graph of y is equal to sin x. How many degrees are needed for this graph or for this function to complete a cycle. Let's check this. The black graph, I'll highlight the first cycle. That's a complete cycle. Okay, from negative 360 to 0, that's a complete cycle. So how many degrees are needed there? 360. Then the graph also will repeat itself like this for another 360. So the graph repeats itself every 360 degrees. The period for y is equal to sin x is 360 degrees. Then y is equal to cos x. The first cycle, see that? That's 360 degrees. From negative 360 to 0, that's 360 degrees. Another cycle. The graph repeats itself every 360 degrees. So that's why the period is 360 degrees for this graph. Y is equal to cos x. And then, what about y is equal to tan x? Let's check our brown graph here. We have this part. That's a complete cycle. From negative 270 to negative 90, how many degrees is that? That's 180 degrees. Then repeats itself from negative 90 to 90, that's 180 degrees. So the graph repeats itself every 180 degrees. For y is equal to tan x, the period is 180 degrees. And then asymptotes. Y is equal to sin x, we don't have asymptotes. Y is equal to cos x, we don't have asymptotes. The asymptotes are for y is equal to tan x. So where do we find them? For this domain, remember we said that the domain of trigonometric functions is from negative infinity to infinity. But now we have restricted our domain to be from negative 360 to 360. So for this particular domain, our asymptotes are at negative 270 and positive 270. Okay, that's where the asymptotes are. And even at what? At negative 90 and positive 90 degrees. That's where you find the asymptotes. Every 180 degrees for this graph. When it's 10x like this, we haven't talked about the change in period. So now we're still dealing with the y is equal to 10x. For every 180 degrees, there is an asymptote. From negative 270, if you say plus 180, you get to negative 90. Negative 90 plus 180, you get to 90. 90 plus 180, you get to 270. So every 180 degrees, there is an asymptote. And then interval spacing. This is very crucial when we're going to be sketching our graphs. Now we usually use our calculators to find our coordinates of the critical points. It is very important that you find the steps that you're going to put in the calculator. There is this little formula that I want to give you, which is going to assist you a lot. So what you do to find your steps, right? What do I mean by steps? Like here, we have this point from 0. We need the point here at 90. We need the point here. We need a point here. So every 90 degrees, there is a critical point. Even for the tangent graph, we have a point there, and then we have a point there. We have an asymptote there. Every 45 degrees, there is a critical point. Okay, so how do you get those steps? You just say period divided by 4. The period will change. It's not always this. It will change. So you have to find your period first, then divide by 4. So in this case, our period is 360 for y is equal to sin x, 360 for y is equal to cos x, and 180 degrees for y is equal to tan x. So we divide this by 4. 360 degrees divided by 4 is 90. Our steps or interval spacing is every 90 degrees. For y is equal to cos x, 360 divided by 4 is 90. And then for the tangent graph, 180 degrees divided by 4 is 45. Okay, so these are the key concepts that I wanted us to revise before we look at the individual graphs in detail.